Now let us understand the kind of a binning techniques that we do have. In one of the previous session, we discussed about a data discretization. What is data discretization? The categorical data should should be converted into the numerical data. For an instance, there is a department. Department has several values such as IT or marketing or something else. In order to convert this into numerical form, we use binning because machine learning only understands numerical values, right? So here we are going to use binning, that is called data discretization. Now we are going to understand this binning by using a real world example. Now see, let's consider a real-time example of a data discretization of the healthcare industry for predicting the disease risk. There is a hospital. In this hospital, there is a customer table. There is a customer data set is being collected. Right now, where this binning is going to be applied. A hospital using the patient data to build a model that predicts the risk of the heart disease. Data set includes continuous variables such as age, cholesterol level, blood pressure, and BMI. Here, this is the continuous data, right? Age is the continuous data in which values will be from 1 to 100, and cholesterol level. Again, it also is a continuous data because there are several discrete values are available, and the blood pressure. Again, this is the continuous values and also the BMI. For instance, instead of analyzing age as a continuous value, as we discussed in one of the previous session, we can bin it to several categories. It might be helpful to group into discrete age ranges. Okay, now age gets divided into 0 to 35, young 36 to 55, middle aged and 56 to 100 years. So we'll be able to spot this. We'll be able to divide this age into only 3 groups. Rather than having different kinds of ages which are spread across unrestricted domain, we have 3 bins in which age has actually been separated into, has actually been categorized into. This type of discretization is simple but ensures that the intervals have equal ranges. This is the advantage. But there is one disadvantage with this equal width binning. This comes under equal width binning. For instance, this is equal width binning what we are talking about. Equal width binning meaning 0 to 35. One width, 36 to 55. Another width, 56 to 100. Another width. This is called equal width binning. The advantage is simple and ensures the intervals have equal ranges. This is the advantage, that whatever we discussed is advantage, but there is a disadvantage. What is the disadvantage? It might not reflect the distribution of data. The most patients are middle-aged. What happens generally? Who goes to the hospital? Only middle-aged people who are in between 35 to 55 will go to the hospital. That bin will fill. The remaining bins will be empty, right? Obviously, from 0 to 35, there will be less entries. From 35 to 55, there will be maximum entries. The other bin will have very less entries. So here, equal division among the bins, you will not be upset. That's the biggest drawback of the equal width binning. Equal frequency binning. It is somewhat yields better than the equal width binning. What is equal frequency binning? In the equal frequency binning, this method divides the data set into bins that each contains approximately the same number of the data points. There, the data points are different, right? 1 to 35, data points will be less, meaning the variables will be less. 35 to 55, variables will be more. 55 to again more, variables will be less. Here, but in the equal width binning, data points will be equal or at least more or less the same. If you use equal frequency binning, the boundaries of the bins are determined based on the data distribution. I'll tell you by a simple example. Now, low cholesterol contains the first 333 lowest calories. Medium cholesterol contains the next 333 values. High cholesterol contains the highest 333 values. Let us understand. Cholesterol level. I just need to divide this cholesterol level. This cholesterol level, if the data set has 1000 patient records, each frequency binning could create 3 bins, each containing around 333 records. Okay, total 1000 patient records. Equal frequency binning could create 3 bins, each containing around 333 records. Now here we are not dividing the patients according to their ages, rather we are going to divide them according to their cholesterol level. 0 to 333, obviously the total 1000 people can be expected to be falling in this category at least equally, right? Or more or less the same. Obviously, cholesterol level will be varied hugely among the patients. First 333 lowest level values, next 333 values, next 333 values will be equally divided into equal bins. That is equal frequency binning. In the earlier case, if you recall, the problem is we have divided, it's the equal width. In the equal width, we have divided 3 bins. In the 3 bins, in only one bin you can find more number of data points. In the other bins, the data points will be less. So here, data points will be equally spread across all the bins. Next thing is decision tree based discretization. What is decision tree based discretization? Simple example. Now the thing is, we are going to take a decision. According to the decision, bins will be created. According to this decision, a data point will be categorized into one of the bins. For an example, age is less than 45. 45 less than age, and age is less than 45 and less than or equal to 65. And age is greater than 65. Age is less than or equal to 45. And in between, age is greater than, this should be replaced. Age is greater than 45 and less than or equal to 65. Age is greater than 65. Now if you divide this, it is based on a decision. Based on the decision, bins will get created. But this decision, it just depends. Decision based bins, of course they may be useful, but these are more custom based. If it is needed, decision based bins will get created. Most of the times we will use the earlier two techniques, not the decision tree based techniques. Benefit bins are based on the relationship with the target variable, leading to more predictive and meaningful categories. Next thing is custom binning. This custom binning will be done by the professionals. The professionals are going to identify the kind of bins that they want. For an instance, a doctor is the right person to identify the cholesterol level. Then he will be able to categorize the patients into 3 different bins. The first one is low cholesterol level, second one is a medium cholesterol level, third one is a high cholesterol level. According to some clinical guidelines and his expertise under the domain, he will be able to do this very efficiently and effectively indeed. These bins will be created in the custom manner by a professional. Okay, so this comes with the expertise under the specific domain. Here, the cholesterol will be divided into 3 categories. One is normal, second one is borderline high, and a high. This can only be done by the experts. Benefit is results in bins that are easily interpretable and aligned with the domain knowledge. The doctor, because eventually this model is going to be utilized by the doctor, and he will be able to use his bins to analyze and predict the data very, very easily indeed. That is the result. But the drawback may not capture the nuisance of the data distribution, because here this is okay. For the doctor it is okay. But how the data is getting distributed, it doesn't make any sense for a non-technical guy, right? So that is what our custom binning. So this is how data discretization is going to be done. Thank you.